So today we'll be talking about isotopes. So what are isotopes? Isotopes are the atoms of the same element having different mass numbers. Okay? In my last video I talked about atoms and molecules. If you have not watched that video, go and watch it. Don't be saying everything I said in that video in this video again. Remember I said that the atomic number is the number of protons and the mass number is the sum of the protons and the neutrons. Okay, so when two atoms of the same element are having different mass numbers, it is that since the number of protons is the atomic number, that is, and both of them have the same atomic number, that's what makes them the same element. So what will make their mass numbers to be different is the difference in the number of neutrons. Let's say chlorine, for example. Its atomic number is 17 and its mass number is 35.5. But this is as a result of the calculations of the isotopes. The chlorine has two isotopes and we call this the chlorine of the mass number 35 and the atomic number 17, and this is the chlorine of mass number 37 and the atomic number 17. So the isotope calculation is about, like, we have this mass number here and we have this mass number here. So what is the general mass number for this element with these various mass numbers? Okay, so the basic calculation is multiplying the percentage abundance by the mass number. That is, if this percentage abundance is 75, that is 75%, we're going to say 75 over 100, that is a percent, times its mass number. Okay, let's take this question further. So we are calculating these two isotopes. So we are going to say the first isotope has the mass number 35 and the atomic number 17, while the second isotope has the mass number 37 and the atomic number 17. Now the percentage abundance of the first isotope is 75, while that of the second isotope is 35. So how do we calculate their relative atomic mass? So we are going to say 75%, that is also 75 all over 100, times the 35, which is the mass number of the first isotope. So we are going to say plus 25%, that is 25 over 100, times the 37, which is the mass number of the second isotope, which is 25 all over 100 times 37. So we are going to say 75 over 100 times 35. If we calculate this further, we are going to get 26.25, and if we calculate this one further, we are going to get 9 plus 2, 5. So adding these two results together is going to give us, that is 35.5. So that is the relative atomic mass of these two isotopes. Okay, so in my next video I'm going to talk about the ions and radicals, how elements give out electrons to form ions. Okay, you should watch out for that video. Bye for now.